Hello and welcome to MAKElog number 11. I have this tiny spectrum analyzer by Texas Instruments. It allows to measure some frequency ranges below 1 GHz. Although TI says it can't be compared to professional spectrum analyzers, I'm curious how it works compared to a bigger spectrum analyzer. This one is not a professional one, but it's a mid-range one. I just take this joystick, which I was using to control the RC car, and this is the battery for the joystick. We have a center frequency of 434 MHz, both a span of 9 MHz. We have a resolution bandwidth of 100 kHz, which can be found here. And we have a frequency step width of 29 kHz, and the same can be found here. It's 29 kHz. So let's have a look. I switch it on. And you can see that the spectrums look similar. We have the center here at approximately 434.016 MHz, and here it looks almost the same. So I'm impressed how this one can display the trace. We can see some sidebands here left and right from the center. We can't see them here. I think this might be something because the signal processing of the small Texas Instruments spectrum analyzer may not be the best. Now I would like to change the resolution bandwidth of the TI spectrum analyzer. I set it to the maximum of 800 kHz. The resolution bandwidth of the HAMEG spectrum analyzer is now set to 1 MHz. I tried to change it to 300 here, but it doesn't look so similar, so I set it back to 1 MHz, and this is how it looks like. I would like to test the Texas Instruments spectrum analyzer for other frequencies. For this I put an antenna to the tracking generator of the HAMEG spectrum analyzer and set it to different frequencies. The TI spectrum analyzer program shows us two curves. One is green, it shows us the maximum over time, so the maximum value that has ever occurred. The red curve shows the actual value. And now I am increasing the tracking generator frequency, and you can see that the green curve is showing where the frequency has been before. The frequency of the tracking generator and of the TI spectrum analyzer perfectly matches, so I'm impressed that you can do good frequency measurements with this spectrum analyzer. I also wanted to test for the 900 MHz frequency range of the spectrum analyzer, but I think unfortunately my antennas are not good for this range. Since I have no other antennas, I have to skip this test. For testing the lower frequency range, I have switched the spectrum analyzer's tracking generator to 0 span, so we are outputting a signal at 325 MHz. And we can see it's exactly what the Texas Instruments spectrum analyzer shows us here. I'll change the center frequency and you can see how it is moving. So the frequency which is measured by this spectrum analyzer seems to be quite precise. I must say that the antennas are not optimal for these frequency ranges I have entered here. Let's increase the width of the span, and I'll change the center frequency, and you can see that the center frequency is changing as I am changing it here. I can also set it to maybe 328 MHz, and you see it appears there. So I think this spectrum analyzer is quite nice. It costs around 200 euros. I think it's $249, and this is a nice tool, very nice tool. I'm changing now the settings back to the first setup when we have tested the joystick. But here the green signal shows us the output of the tracking generator, which only works at one frequency. So since the tracking generator is not modulated, the spectrum is quite narrow. Let's switch on the joystick and you can see that the spectrum gets broader and the joystick has a higher output power. So, I hope you enjoyed this setup and I could show you something interesting, and I hope to see you again.